Hello everyone, my name is SUYASH PAWAR from MIT Academy of Engineering, Civil Engineering, Pune. Today I am presenting the topic is Introduction to Bridge Engineering. In this topic we are discussing about the types of bridges, how can bridges take stress and the components of the bridges. So bridges are the vital for connecting places and enabling transport across obstacles. This presentation covers bridge classification, components, design concepts, loads, failures, and the maintenance. We highlight both historical context and the modern engineering advances. So we move ahead. So first we start that classification of the bridges. By function, we are classifying the bridges by the function. So first type is adequate bridges, uh, highway bridges, railway bridges, and pedestrian. In the highway bridges, the bridges are manufacturing on the highway are called as highway bridges. The railway bridges are also that manufacturing to transport the railways are called the railway bridges. So differences by the function is that on the highway we are designed the bridges to pass load carrying heavy loads like uh, trucks, trailers, and etc. And for the railway bridges, we are applying the load that carries the railway, like uh, material transporting railway and etc. So the second type is by the structural form, beam, arc, suspension, cable stand, and truss. So these are the types of bridges by the structural form. The next one is by the material. So the bridge which is made by the steel are called as steel bridge. After the some bridges are made up by the concrete. Some are from the timber and some are from the composites. So now in the current scenario, mainly concrete and steel bridges are in the lead in India. Example like Golden Gate Bridge, which is the suspension bridge in India, and the second one is uh, Akashi Kaiko Bridge. In the cable, it is the cable stayed bridge. So next one is the components of bridges. So the main components of the bridges are here. So first is superstructure. After that in substructure, then the bearings and the function. So in the superstructure, deck. Deck is the surface of traffic. Deck is the surface of traffic in which on which the all the traffic moves ahead. Second one is the girders, trusses, arcs, and the cables. So trusses are the steel members which connect the entire bridge, and arcs and cables are also the taking loads. Cables which is are made up of the tendons. Second one is substructure. So in the substructure, first one is the piers on which the total load of bridge are gathered and transferred to the ground. Second one is abutments, and third one is the foundations. So we all are familiar about that term that piers and foundations. So piers are settled on the foundations of the which is situated in the ground. So if we have to better and good quality and high strength bridge, so uh, we are having to maintain the foundation and the piers and good strength of the piers and the foundation. So next one is the bearing. So fixed bearing, expansion, rockers, and roller types. It is the types of bearing, and the function is each part transfers the load safely to the ground and allows movement. So on the superstructure, which is directly in contact with the heavier vehicles or etc., they transfer the load. Like deck is transferring the load to the substructure, which are the piers, and after that, substructure transferring the load to the bearings and etc. So next one is the economical span, flux, HFL, and the scour depth. So economical span in the balancing superstructure and substructure cost for efficiency. A flux. In the flux, water level rise due to the bridge obstruction. Example 0.3. So bridge, we normally why we are making the bridge. So over a river and the canals, which is mainly in the rainy and high river areas where the river and the concentration of water level is high. So we are having to provide the height of bridge like that. So afflux is the water level rise due to the bridge obstruction. Third one is HFL, high flood level. So in the high flood area, the maximum recorded water level, example, the 105.5 meters in the areas like where the flood is occurring in many seasons. So HFN is the high flood level and the scour depth. So erosion around the foundation calculated with the formula is called as scour depth. Next one is the loads on the bridges. So what type of loads are occur on the bridge? So first one is dead load. The dead load. So self-weight of materials like steel, concrete, and etc. The cables, tendons, and also uh, whatever the material which is made whole free are called that dead load. So concrete, which is density of the concrete is 24 kilonewton per meter cube, and the steel density of steel is 77 kilonewton per meter cube. So all the material, this concrete and steel, are considered as a dead load of any tree. Next one is a live load. So vehicular traffic and pedestrian load. What is vehicle live load? So all the cars moving on that particular bridge are considered as a live load. And after that, pedestrian load means all the human and etc. which we are applying on it. Like in some areas, heavy trucks and population is more. Live loads are that environmental load. So wind load, seismic analysis. We are hearing the word that seismic analysis and etc. So the in the hilly areas where the uh, density of air and etc. is normally higher from the uh, other is in that area, environmental loads are. So are moving. Our next is IRC load specifications. So in IRC standards, Indian Road Congress governs the bridge design loads and the materials. So load combination. So dead load plus live loads plus impact plus wind for safety cracks. All these load are combined to load combinations. And the next one is the vehicle cases. So in the class A, which is heavier, like truck, trailers, and all the tractors and all the heavy vehicles which is transporting goods and carriers are considered as the class A. Next one is class A, only class A. So in class A, the normal load vehicles like uh, lower cars and the vehicles like uh, mm, buses and etc. are considered as in the class A. And in the class B, motorcycles, cycles, and uh, all etc. The all other vehicles are considered in the class B. And material spaces in the IS6 details material strength are properties. So moving ahead, design consideration, limit state design. So in collapse limit state, ensure the strength and structure stability under the max load. In the second stability limit state, controls deflection, vibration, cracking, and for usability. And the next is max permissibility deflection for simply supported bridges. Common bridge failure causes. So why the bridges are going to fail? Hydraulic failure. So scour and erosion causing the foundation weakness, and because of the weakness of the foundation, bridges are collapsed. So mature dam case in our it is the best example of the failure of the bridge. Structural failure, overloading, design flaws, and material degradation. So structural failure. If we are designing the bridge for the 100 kilonewton and if we applying the 1500 kilonewton load on it, so it is directly going to collapse. Best example is the Kolkata flyover 2016 and the constructional failure. So poor erection and workmanship lead to early damage. If we are using the low quality materials, low quality design and low quality steel, etc. in the our bridge, so it is directly responsible for the failure, and it is included in the construction failure. Next one is the uh, case study, bridge failure in India. So, Machu Dam in 1979, the failure due to floor score and the hydraulic pressure, Kolkata flyover. So, collapse caused by the design flaws and poorly maintained joints. So, in the joints which is connected by the bolt and nut and bolts, or some joints are connected with the welding. So because of this, a collapse caused by uh, collapse is happen, and other failures in the frequently score and overloading highlight with monitoring. The last one is the bridge maintenance and rehabilitation. So in regular inspection, we have to inspect regularly on the bridges. So we are getting the life of better life of the bridge. Frequent checks it detects the wear and the early problems. So uh, next one is the non-destructive testing. So there is the various testing in the market. So non-destructive testing is the one of them. So ultrasonic testing in ground penetrating radar enhances the safety. It is the advanced technology to detect the uh, bridge quality. Next one is the strengthening techniques. So methods like jacketing and the FRP composites extend bridge lives and the proactive maintenance. So they need prevent the costly failure and ensure infrastructure reliability. So thank you. Meet us in the next video.